Hello everyone, and welcome back to another episode of Bo Maths. How are y'all doing today? So in the last couple of videos, we looked at the ideas of divisibility, factors, and multiples, and today we're going to get a little deeper of a view on those ideas. And to start with, we're going to look at the relationship between divisibility and factors. So I kind of talked about this indirectly in the last videos. We're going to clarify the relationship between divisibility and factors explicitly here. So we say this. If a number is divisible by something, then that something is a factor of the number. And for those of you who might think like this wording with like a number or something is kind of unsatisfying, you're right, it is unsatisfying. Once we get into the language of algebra, we're going to be able to frame this in a lot more precise of a way. But until then, we're kind of forced to speak a little bit indirectly, where we're talking about some number and it's divisible by some other number. But that's all right. So let me give you an example to clarify what this means. So we know that 10 is divisible by 2, right? And the reason for this is that 10 divided by 2 gives us a nice whole number. But for those of you who know the fact that division and multiplication are like opposites of each other, you'll know that this corresponds to the fact that 10 equals 5 times 2, right? Where we know that since 5 times 2 equals 10, we know that 10 divided by 2 equals 5, or that 10 divided by 5 equals 2, right? This is information that we can get from the fact that 10 divided by 2 equals 5. But from this statement, we see that, hey, 5 times some whole number gives us 10, and 2 times some whole number gives us 10. So that means 2 and 5 are factors of 10. So 10 being divisible by 2 also means that 2 is a factor of 10. So since 2 is a factor of 10, 10 is divisible by 2, and since 10 is divisible by 2, 2 is a factor of 10. So these are just kind of saying the same thing. Now that we know kind of how to convert between one and the other, we're going to get into the main focus of this video, namely divisibility shortcuts. So the methods that we were using in the last video would be something like the following. So if we look at 24, we can look at if 1 is a factor. Yeah, it is, since 1 times 24 is 24. So 1 being a factor also means that 24 is divisible by 1 by using the equivalence we just got up there. If we look at 2, yeah, 2 works since 2 times 12 is 24. 3 will work since we know that 3 times 8 is 24. 4 will work since 4 times 6 is 24. And 5 does not work since if we count by 5s, we'll pass 24. And then we'll get to 6 again. But if you remember from last time, these factors are going in ascending order. These are going in descending order. So we're just going to be repeating these factors over here if we continue with the list. So we know that we have all the factors here. 1, 2, 3, 4, 6, 8, 12, 24. So this was the way we found all the factors, was just simply do these numbers, multiply to give us 24. But these were for smaller numbers, right? If I give you something like 1058, we might not as easily be able to tell if these numbers are factors of this or not, or if this is divisible by those numbers or not. It's not as clear cut anymore. So instead of having to divide the number and see if it gives us a decimal or not, we actually are able to get some shortcuts to determine if this number is going to be divisible by that number or not, or equivalently to determine if that number will be a factor of this number or not. So let's look at some of those right now. All right, so if you recall, anything is divisible by 1, right? Anything is divisible by 1. So we don't even need a divisibility shortcut for 1. It's just simply we automatically get divisibility by 1, or equivalently, we automatically get that 1 is a factor of that number. All right, but let's look for the rule for divisibility by 2, because that's definitely not the case that every number is divisible by 2. Spelled it wrong. By 2. All right, so let's start looking at the numbers that are divisible by 2. Well, is 1 divisible by 2? Nope. How about 2? Yep. How about 3? Nope. How about 4? Yep. 5? Nope. 6, yeah, right? So if we just count by 2's, we will find the numbers that are divisible by 2. But counting by 2's, what types of numbers does it give us? It gives us all of the even numbers, right? So even numbers, that means it is divisible by 2. Odd numbers, well, that's 1, 3, 5, 7, right? Those ones were not divisible by 2. So our test for if a number is divisible by 2 is if it's an even number or not. And to be an even number, the number simply just has to end with 0, 2, 4, 6, or 8. So for example, the number 1080 is even since it ends in a 0, and therefore is divisible by 2. The number 10,454 is even because it ends in a 4, and therefore it's divisible by 2. The number 3,478,251, that ends in a 1, so that's odd, and therefore is not divisible by 2. Or another way of saying these is that 2 is a factor of 1080 because it's even. 2 is a factor of 10,454 because it's even. But 2 is not a factor of 3,478,251 because that is an odd number. And this is a really powerful method because we don't actually have to divide these numbers by 2 to actually check if we get a decimal or not. We simply just know if it's divisible or not by looking at if it's even or odd. So this is the kind of shortcut that I'm talking about, where we can just look at some property of the number and be able to determine aspects of it without actually having to directly check those aspects itself. So we have a shortcut for divisibility by 2. Now let's check it for divisibility by 3. So let's list some of the numbers that are divisible by 3, which we just get by counting by 3's. So that's 3, 6, 9, 12, 15, 18. Right, just like this, and we can keep going. And counting by 3's, these are also the multiples of 3. So we can say that all the multiples of 3 are divisible by 3. It might be a little harder to check what these numbers have in common because we see that, yeah, some of them are odd, right? Like this 3, 9, 15, 21. But some of them are even as well, right? Like 16, 12, 18. So we won't be able to use even and odds for our checking method. And for the rule for divisibility by 3, it's a little more complicated than just simply looking at evens and odds. What we have to do is we have to add the digits of the number. So you add the digits of the number. If the sum is a multiple of 3, the original number is divisible by 3. If the sum is not a multiple of 3, the original number is not divisible by 3. All right, so let me clarify what I mean by this with some examples. So let's look at 27. Now 27 in this list, it's a multiple of 3, so it's divisible by 3, right? But we can also check that by looking at the digits. So the digits are 2 and 7 and adding them together. And 2 plus 7, that's 9. Is 9 a multiple of 3? It is. So 9 is a multiple of 3. And thus 27 is a multiple of 3. Or it is divisible by 3. Right? If something's a multiple of 3, that means it is written as 27 is 3 times some number, which means that 3 is a factor of 27, which means that 27 is divisible by 3, right? So we also get that being a multiple of 3 entails that 3 is a factor or that it is divisible by 3. But in any case, since by this rule we have that the sum of the digits gives us a multiple of 3, and therefore our original number has to be divisible by 3. All right, let's do another example. Let's go with 13. So I know 13, that's not in this list, so it shouldn't be divisible by 3. And if we add up the digits, we get 4, which is not a multiple of 3. And that means that our original number is not divisible by 3. But we can do bigger numbers, right? Because that's the real application of these divisibility rules is for larger numbers where we can't just easily check if the number is divisible by 3 or not. So let's do something like 4,602,001. All right. So if we add up these digits, 4 plus 6 plus, well, we can add the zeros, but adding 0 doesn't do anything, so I'm going to skip over that. Plus 2 plus 1. What do we get? Well, 4 plus 6 is 10, plus 2 is 12, plus 1 is 13. 13 is not a multiple of 3, and therefore 4,602,001 is not divisible by 3. And we didn't even have to divide it to check, right? All we had to do was just do this simple little shortcut, and we can see that it's not a multiple of 3. Now, if you don't believe me, which I always encourage some skepticism when it comes to learning, I'll show you on the calculator right now that we're going to get a decimal when we divide it by 3. And I divide that by 3. Let's see what I get. Yeah, see, I get a decimal right there. So it is not a multiple of 3, or it is not divisible by 3. Let's try another example. All right, so let's add up the digits and see if we get a number that is a multiple of 3 or not. So 7 plus 4, that's 11. Plus 2 is 13. Plus 2 is 15. Is 15 a multiple of 3? It sure is, right? 3 times 5 is 15. So 15 is a multiple of 3. So therefore, 74,202 is divisible by 3. Right? So again, we didn't even have to check if we divided this by 3, we got a decimal or not. We simply know from this rule that it's a multiple of 3. Now, I do intend on showing you why this rule works. I believe it's always important to know why things work the way they do. However, we're going to need some algebra tools in order to actually show why this works. So until then, you're just going to have to take my word for it. But do a lot of examples and you'll see that it's going to work in every single case. And it's a really, really helpful tool that we're going to be making a lot of use of in the coming videos. So let's move on to the divisibility rule for 5. So I am intentionally skipping divisibility by 4. I'm going to be covering that in another video. I'm just going to cover like the simplest divisibility rules for this video, and then we will cover other ones in future videos. So let's look at divisibility by 5. So if a number is divisible by 5, that means it's going to be a multiple of 5. So we can start by listing the multiples of 5 and see if we notice a pattern with these. So we have, oh, I missed 10. So we have 5, 10, 15, 20, 25, 30, 35, 40, and so on and so forth. So what do we notice about all these multiples of 5, or all these numbers that are divisible by 5? Well, they all end in a 5 or a 0, right? And it alternates. So we can say then that if a number ends in a 5 or 0, it is divisible by 5. So this is a fairly simple divisibility rule. It's as simple as looking at the number it ends in and then we know it's divisible by 5 or not. So for example, 2,107,010,469 does not end in a 0 or 5, and therefore is not divisible by 5. It's a massive number, but all we had to do was look at divisible. Oops. It's a massive number, but all we had to do was look at the last digit to know if it's divisible by 5 or not. All right, so it's a really fast way of knowing. All right, let's try another one. 740 trillion. This is a really girthy number. 12 billion. 467,204,420. That does end in a 0. So therefore it is divisible by 5. It's as simple as that. Huge number, we don't have to divide it, we don't have to worry about anything except the final digit because of this pattern that we noticed with multiples of 5. So it's got to be divisible by 5. All right, the next rule we're going to look at is divisibility by 9. Again, we're skipping a lot of the numbers in between, but we will cover them in a future video. But 9 is another kind of fundamental one I want to look at. So we can look at some of the multiples of 9 to get an idea for what's going on. So we're just counting by 9s, adding 9 every single time. So if we look at some of these, it might not be super obvious as to what it is, but I'll give you a hint. Try and think about the divisibility rule for 3. All right, so what does that remind you of? Well, if we add these digits, let's see what we get. So we have 9 here. That's just 9. If we have 18 here, we'll do 1 plus 8. Oh, that gives us 9. 27. Oh, 2 plus 7. Hey, that gives us 9. 36. 3 plus 6. Hey, that gives us 9. 45. 4 plus 5. Oh, snap, that gives us 9 as well. And we'll see for all of these, we're going to get 9. All right? So all of these numbers are divisible by 9 because their sum gives us a multiple of 9. Now, in all these cases, the sum gives us exactly 9, but I could do a bigger number like 304,902. And if we add up these digits, we get 3 plus 4 plus 9 plus 2. Again, we don't need to worry about the zeros. That's 7 plus 9 is 16 plus 2 is 18. Now 18 is a multiple of 9, so this should hopefully be divisible by 9. And we can check with a calculator just to verify the theory. 304,902, divide that by 9. There you go, no decimal, so it's divisible by 9. So again, this is something I will prove in the future for all numbers using algebra, but for the time being, you can just try a bunch of examples and see it'll always work. So the rule will be if the sum of the number's digits is a multiple of 9, then the number is divisible by 9. If the sum is not a multiple of 9, then the number is not divisible by 9. All right, so for example, 47, if we add those digits, we're going to get 11, which is not a multiple of 9. So 47 itself then is not divisible by 9. All right, we could try another number. Let's go with 999,207. If I add up all these digits, let's see what we get. 9 plus 9 plus 9 plus 2 plus 0 plus 7. I didn't have to do the plus 0, but oh well. So 9 plus 9 plus 9. Well, that's 3 times 9, which is 27. Plus 2, 29. Plus 7, 36. Is 36 a multiple of 9? Yeah, 9 times 4 is 36. So this is a multiple of 9. So therefore, this is divisible by 9. All right? So hopefully that makes sense. And we're going to do one more divisibility rule before we wrap up for the day. And this is one of the easier divisibility rules. This is divisibility by 10. So if we count by tens, 10, 20, 30, 40, it should hopefully be pretty clear what all of these numbers have in common. They all end in 0, right? So that is going to be our divisibility rule. If a number ends in 0, it is divisible by 10. All right, well, that's pretty simple. We can do some examples to check right away. 349,202. Well, if I count by tens, when is there ever going to be a 2 in the ones place? There isn't, right? So since there isn't a 0 in the ones place here, this is not divisible by 10. We don't need to divide by 10. We don't need to do any complicated math. We just look at the last digit. It's not a 0, so it's not divisible by 10. Another example, 491,304,000. That is divisible by 10 because the last digit ends in a 0, right? So it's as simple as checking that. So I encourage you to review these divisibility rules, check a bunch of numbers. Of course, I'm going to give you a practice video in my next upload. But until then, you can just try some with any number to see if it's divisible by any one of these. And I encourage you to do some experimentation to see if you can figure out some divisibility rules for some other numbers, but we will go into that in future videos. But ultimately, the takeaway here is that instead of dividing by these numbers to see if it's divisible, there is shortcuts by looking at the properties of these numbers. And that's a big theme in mathematics. Instead of doing things by brute force, can we find some sort of pattern or property to some sort of phenomenon? And if we can, it ends up becoming a lot easier to compute things and a lot easier to actually understand what's going on. Just like with all these divisibility rules, instead of doing these massive numbers, right? I give you some really big numbers, like even in the trillions, it didn't actually end up mattering. All it mattered was just some of the properties of the number that we could very easily see and determine for ourselves. So this process of simplification by looking at the patterns is a recurring theme, and I think part of the power of mathematics that it has to offer. But that's going to do it for me today. Have a good one, stay groovy, and I'll see you in the next video.